Okay, so what should the future of modeling look like if you wanted to operationalize climate modeling? Here are the thoughts of the authors. Obviously, need not be, sacrosanct. There are several possible futures for the climate modeling enterprise. A business as usual strategy with research and understanding at the core will continue to advance our understanding of the climate system. The increase in the number of climate models will probably continue, with these models utilizing more and more high performance computing resources and spreading human resources increasingly thinly. Exemplar groups that impose rigorous model development standards will not be advantaged over those that do not. Depending on the future distribution of research funding, modeling groups will appear and disappear. International modeling infrastructure such as the Earth System Grid Federation (ESGF) will require constant research funding renewal, with the very real possibility of losing significant capability based on national funding decisions. Past evidence suggests that the research community itself will probably be able to ride these waves of uncertainty. However, this strategy will not provide society with the best and most robust and actionable information for decision making that is so urgently needed. This is coming from an angle where that climate models exist. They are run routinely. They make projections every few years, and they need to improve. And to make them improve faster, we need dedicated funding, and operationalizing is the way to do it. There are lots of other issues as to whether they should completely reconsider how the projections themselves are done. Let's say now lots of scenarios are done for the future out to 2100 and beyond, as I said, and they give you a range of future scenarios, emissions, and everything else. As I said before, they don't produce regional information right now, but let's say with computational power, the resolutions of the models increase, which will definitely increase the scale of temperatures at more and more regional scales, and then there are other ways of reducing them to local scales. A lot of people use AI and so on and so forth now, but the question is, when we want to worry about policy decisions, societally relevant information, do we really need to go out to 2100? Because the model simulations all agree with each other out to about 10 or 20 years into the future, because internal variability of the models and model uncertainties dominate the simulations. Beyond that, it's the scenario uncertainties that begin to dominate the warming levels, the associated extreme sea levels, and all the other outcomes, including fisheries or agricultural impact and so on. So if you switch the philosophy and just try to do decadal forecasts, so that you just extend the weather forecasts to seasonal to interannual climate forecasts and climate models, then this class of models worry about decadal forecasts. Will that improve things in terms of making the information usable for societies? That's a separate issue which is not discussed here. To best serve society, so from this angle, climate modeling for decision making needs to be urgently given a similar status to NWP without worrying about whether 2100 is useful or not, and this needs to be made operational. This will probably lead to the establishment of several operational climate modeling centers around the world. While the number of operational centers will be smaller than the number of models used in phase 6 of CMIP, it will be closer to the number of truly independent models in previous CMIP ensembles, which is about 10 or so. So do you really need so many models, even though they are following the same protocols and producing lots of information? And there is always the argument that ensemble means improve the overall projections, like ensemble predictions are better than deterministic or single realization, because real world tends to have many potential evolutions, and you cannot capture all of them if you make one simulation, but there are ways to perturb the way you integrate forward or how you start and integrate, and that gives you a range of solutions. So multi-model ensembling is another way to do the ensembling. These centers would, in an operational setting and in strong collaboration with the user and research communities, apply climate models to provide climate information that is relevant to all sectors of society, as we will read in a minute. Making climate models operational would not only provide more tailored and robust information to decision makers, but also simplify modeling for the IPCC assessment process. Operational centers would commit to providing the model predictions and projections needed and ensure their timely delivery, which in the current process is frequently compromised due to the strain on the research community. So here we are combining predictions and projections, so you have to figure out exactly how this will be operationalized as opposed to just weather prediction. Okay, ensembles could be more rationally designed through collaborations across operational centers, providing better estimates of uncertainty as a result. Key questions are being looked at here. More direct lines of engagement of the operational centers with the IPCC assessments on impacts, adaptation and mitigation could more directly inform the model and ensemble development process. So this is not talking of separating the climate prediction models in the operational centers from the projection models used in CMIP suites, but somehow merge the climate prediction and projection models in an operational sense. So let's look at what we mean by operational climate modeling here again. Operational climate modeling centers will develop model configurations focused to serve the needs of policymakers, businesses and planners in the areas of climate risk, climate solutions. Each model will be subject to independent evaluation, code compliance testing, benchmarking and testing with clear communication of strengths, weaknesses and uncertainties to climate services and its users. So you are now talking about not just projections but also actual climate predictions for sectoral uses. The needs of the users of the information will directly connect to the decisions on what developments would be prioritized for the next generation of models. Every country should have a defined pathway to get the climate services information they need, influence what is produced and be supported in using information provided. The operational centers will deliver information that is directly applicable to societal decision making, to climate services that strongly engage with the user communities. The operational use of climate models is complemented with a strong research effort both within a modeling center and through partnerships with other research institutions and academia. By partnering with operational efforts, research models will not only continue to advance our understanding of the changing climate system, but also strongly drive the development of new approaches for operational modeling systems. The liberation of the research community from having to provide de facto operational model simulations will probably spark a renewed enthusiasm in developing new models and applying them to some of the most burning scientific issues that the climate science community is facing. Furthermore, the resulting thriving community of climate modeling for research will enable closer interaction with the researchers engaged in examining the limits to adaptation to climate impacts and identifying new opportunities for climate change mitigation. You can read it again, but basically you understand that we are not really separating now. We have just separated weather prediction and climate modeling and climate prediction and projection. In the real world, the climate projection community is very different than the climate prediction community right now. In fact, under WCRP, there is a World Meteorological Organization which even does multi-year predictions and coordinates seasonal predictions, seasonal outlooks and so on. So this article is kind of mixing those things here. Looking at decision making and research, here you have operational climate models which interact with climate models at research level, and these go with evaluation, benchmarking, interoperable coding, model configurations and ensemble design to optimize ensembles. Simulations are then used for impacts and solutions modeling, and then climate services serve policy, risk, and solutions, and then they feed into model development, which goes also into climate models under research, which is serving CMIP and Cordex. So now they have combined clearly both of them here. So ensemble of opportunity that we discussed before, with climate system research, impacts research, solutions research here, and understanding the limits of to adaptation and opportunities, and again improving the models to serve this research aspect. Is this somehow separating, or is it really mixing two different things? This is going on its own, this is going on its own. This is definitely happening without having operational centers, even though labs have dedicated themselves to several cycles of CMIP already, and they do improve the models. They go towards Earth system models, dynamic vegetation models, carbon cycle, and so on and so forth. So let's just summarize then. Climate change is here, and the information about its potential consequences has become central to decision making, from setting global mitigation targets to assessing climate change risks at local scales. Our knowledge of possible future climates rests strongly on the availability of the best models of the climate system we can design and their application to societally relevant questions. The current focus on climate modeling as predominantly research activity is unlikely to deliver the best outcomes for society, as well as perhaps paradoxically climate science itself, as models are not designed for climate service delivery. They do not deliver the bespoke information required. At the same time, climate research slows down as modelers juggle quasi-operational commitments with developing model improvements. Finally, the fickle nature of research funding prohibits sustained strategic efforts to build bespoke models, as the goalposts for model development continuously shift. Decades of experience in numerical weather prediction have shown that decision makers, and indeed public, are best served by operational modeling systems, but this is a bit of an apples to oranges, because numerical weather prediction models provide forecasts that can immediately be verified, and people are upset when you are wrong, and if you're consistently wrong, and you will get a lot of feedback, whereas climate predictions like El Nino, monsoon also get continuous validation, skill assessment, whereas projections are something else. So we have to be sure what we are talking about. Given the maturity of climate modeling and its de facto use in societal decision making, it's time to learn the lessons of the NWP and apply them to the design of operational climate modeling systems that put decision making front and center in their design and application. The resulting models will be central to the sustainably funded, well-resourced, and bespoke climate information systems the world needs to support decision making in climate change mitigation and its implementation, as well as in adapting to the changes that are no longer avoidable. So again, I see mitigation as a long-term goal, whereas adaptation is got two components. One is adapting quickly to the changes like heat waves, extreme events, floods, droughts, whatever. But then there is the resilience building, which requires a whole set of other criteria that are not just about getting very reliable climate information, but also having the engagement of the society, the budgets, the governments to make sustained investments in infrastructure, and incentivizing people and firms to adapt, and so on and so forth. And then there is a community of Tim Palmer, Julius Lingo, Bjorn Stevens, and so on from Europe largely, who argue that this class of models is never going to provide information that is reliable at the scales that are needed for societies. So they argue that a K-scale model, kilometer scale global model, is what is going to save the day in terms of providing realistic information, and they imagine doing that for seasons to decades, let's say. So that transitions from climate predictions, as happens now, to climate projections, as happens now, but in two different communities. So that's a whole different argument, as opposed to just operationalizing CMIP class models or climate forecast models. So this uh, opinion piece in that sense is a bit muddled. So you go and figure out how you would think about this, because I do have a separate podcast on K-scale modeling, because there is a nice paper that was put out by the group that I mentioned for for arguing for K-scale modeling as the way out of these uncertainties that we mentioned here. Okay, complicated issue, but decisions have to be made either way. So we'll come back and discuss the next topic, which will be should I say what it will be? Let me see if I can say. Yeah, let's see. It'll be about pollution reducing or some such thing. See you anyways in the next podcast.